vectors, or this is also called as Lami's theorem. One of the consequence of triangle of vectors is nothing but Lami's theorem. So in the addition process of vector, let us see this particular second one, Lami's theorem. In this particular Lami's theorem or triangle of vectors, first of all let us see the definition of triangle of vectors. Suppose two coplanar vectors are like this initially. This is A vector and this is B vector. Then the addition of vectors must be done from starting point of first vector to the ending point of the last vector. That is called what? Addition of given two vectors. If we take that the resultant vector in the reverse direction means in this direction, then what happens? Whatever the condition we are imagining here, starting point called as origin O. So at O what happens? This is the first force A bar, this is the second force B bar, ultimately this is the third force C bar. As a result, in the coplanar we have this particular point is at what? Equilibrium. So what is the statement in the triangle of vectors? Nothing but if three coplanar forces are acting at a point O to keep it in equilibrium, then the summation of three vectors A bar plus C bar plus C bar is equal to 0. This is the condition for the triangle of vectors. Now what is the similarity here over the Lami's theorem? Here in the Lami's theorem, what it will gives us is simple logics. The angle opposite to the first vector, that is called as alpha, and the angle opposite to the B, that is called as beta, and the angle opposite to the C called as what? Gamma. Then what we write down according to Lami's theorem, that is the magnitude of vector A bar by sine alpha is equal to the magnitude of vector B bar by sine beta is equal to the magnitude of vector C bar by sine gamma. This particular mathematical equation is called as Lami's theorem. Now let us see one example so that you can understand. Example. In the system like this, imagine that this is the wall and this is another wall. Between the two rigid walls, suppose an object of weight W is suspended like this. An object of weight W is suspended like this. And the angles are given by here some 30 degrees given, here also 30 degrees given. Then we have to find out the value of tension T1 and tension T2. For our simplicity, instead of 30 degrees, let us see a small small difference or small deviation here. Just 45 degrees. Let us study. Imagine here. So here 45 degrees. Let us study. Imagine. We have to find out the tensions T1 and T2. Then how to find out the value of T1 and as well as T2 using this Lami's theorem? To solve this particular Lami's theorem, we need to follow the following procedure. Number 1. Step 1 or the first step. First of all, in the given figure, try to identify the neutral point. So in the given figure, so here what happened here, 30 degrees given, and beyond here it is 45 degrees, and another weight W is there. System is in equilibrium, is no doubt that is this particular position. So with red color marking, this is called as equilibrium point. So we got this called as equilibrium point. Now in the step 2, we have to plot the x-axis and y-axis at the equilibrium. So we are just plotting the x-axis and y-axis here, the equilibrium point. So first one and this is second one. We plot the x-axis and as well as y-axis for the figure. Now let us try to analyze further. In the step 3, we have to identify alpha, beta and gamma angles in the problem. So how, sir? Let us see. In a given case, Here already 45 degrees given, here 90 degrees, therefore here there should be 45, already 90 degrees is there. This total angle going to be 90 plus 45, nothing but 135 degrees we can write down. Here 30 degrees means no doubt that is here also 30 degrees and here 90 degrees is there. Therefore here up to here we have an angle of 120 degrees. What about this remaining angle? So out of 360 degrees over the full circle, 130 minus 135 let us do. And as well as from this we have to separate again minus 122 minus we have to do. That means 360 degrees minus 255 we have to do. So therefore here we are getting 5 and so 0, 105 we are getting here. So therefore we can write down as 105. Now at this particular case we got first one is what step 1. So we'll try to apply after determination of angles. In the step 3 we have to apply direct, step 4 we have to apply directly Lami's theorem. So first known weight W by what is opposite angle sine 105 here, which is equal to, and here in the problem given what, let us identify these particular values are these particular value as T1 and this particular value as T2 force. Then we can write down as what, T1 by opposite angle sine 135, which is also equal to T2 by, so T2 by opposite angle will be 120, therefore we can write down as sine 120. Using this you can find what as T1 is equal to sine 135 divided by sine 105 of W, because by just doing cross multiplication over here. Similarly, by doing cross multiplication with the first and last terms, you will get what, T2 in the given problem. So by using this, one can identify this particular example.